My guest today is Jay Tower. Jay, how are you, my friend?
Doing well, David. Nice to see you.
Nice to see you. It's been a while since you've been on my show. Remind us what you do for a living.
Sure. So I own a software consulting business. It's called Trailhead Technology Partners. We do custom software development consulting, help our clients build custom software to solve problems, run their business, interact with their customers, etc.
I know you're talking a lot these days about over-engineering software projects, and I'm guessing you take that you're against it. You like simplicity as much as I do, but you've got something to talk that's titled something like over-engineering. And tell me about that. What inspired you to give this talk?
Yeah, that's right. So the full title of the talk is Avoidifying Overcomplexification, which I think is a fun title.
You could probably
But
that title is probably over-engineered.
it is a little bit, yeah. But what's funny about that title, I think, is that it gets a lot of people into the room because as soon as they read it, they understand because they've experienced the software version of that title. But it started like all the way back at the beginning of my career. My first consulting job ever, 20 something years ago. I I started out at, it was a .com startup that dates me a little bit, but they had built their software in such a way that it could have the database layer swapped out. So it was built on top of Oracle DBMS, but it was written so that SQL or MySQL could be swapped in at any moment. And it wasn't like it was installed locally in different environments where it needed that. It was a SaaS solution essentially. And so you can imagine how many times we actually swapped out the database layer,
I'm
zero.
guessing it's less than one. Yeah.
Yeah, exactly. And that got my juices flowing even back then about like, oh, this has created a lot of extra work, a lot of extra testing, a lot of extra
Yeah.
surface area for bugs, and it's no benefit. And then over the years, just working with hundreds of different software consulting clients and seeing all their solutions and realizing how common over engineering is, I started trying to kind of capture from those experiences a list of the most common types that I see, and then some things that I think you could do to, as a team or as an individual, to kind of help avoid those.
I can totally relate to that. During my consulting days, I once had a project where they not only were able to swap out the database, but there was an ORM on top of the database. During the .com days, I don't know if ORMs existed, but they had built it in such a way that they could swap out the ORM.
Mm-hmm.
So if you got tired of in Hibernate, you could use link to SQL, for example.
Yeah.
And it was solving a problem that didn't exist. So all that complexity they were adding added zero value at all. It was there just in case somebody wanted that kind of flexibility.
Yeah. And that's a perfect example of one of the kinds that I think is common. I call that over abstraction. That's
Yes.
where you basically say, what if we want to swap this out at some point, even though maybe the only argument in favor of swapping it out is that you were burned at some point in the past with something that you couldn't swap out that you wanted to. But we
For
all
that
wish we could.
example, I have no idea what the motivation was because the engineer who had designed it and architected it had left the project already.
Yeah, sometimes you lose that info
So
when,
we
when
had we
people
had
leave
no
the team.
architect, but he
Yep.
left behind this extra complexity for us to
Yeah.
suffer through. All right, so let's get specific. You're not just whining about over engineering. That you've seen specific problems and you've got specific solutions. Let's talk
Yep.
about some of those.
Yeah, so there's not exactly like a one-to-one mapping between the problems and solutions, and as you can imagine, even the problems have, if you Venn diagrammed them, there's a lot of overlap between
Hmm.
these different categories. You could argue that some examples fall into two different categories or whatever, but it's more things to kind of get you thinking about the types of things that we do as humans to over-engineer our software. So I mentioned over abstraction. That's basically where you write a layer on top of your layer, just in case the layer below you want to take out at some point, even though you're never going to. Uh, the most common type is probably developer gold plating. I think a lot of people have heard that term before. There's also another kind of gold plating that uh, that maybe people have heard of, which I would call like user or business user gold plating. And another word for that is just scope creep, right? That's
Right.
when people ask you to do things that weren't in the original plan. But developer gold plating is arguably a little more dangerous. This is when developers start adding extra features that weren't in the requirements.
Hmm.
And the thing that's more dangerous about that is if a scope creep happens. So if your users or your business users are giving you extra features, everyone kind of knows that that's happening. The developers know, the business users know. But when developers gold plate, it's usually secret. It's behind the
Right.
curtains, and not everybody knows. So there's no even if there is a good reason to do it, there's no chance for the whole team to kind of make a decision about that. And so a bunch of time gets sunk into making something so perfect that it doesn't even need to be that perfect, instead of focusing on developing the features that are important.
So maybe somebody later on tries to go into the code and make a modification, and it's not at all what they've expected. It's using, I don't know, some shiny new toy, some tool that very few people are familiar with.
Yeah, good.
I'm guessing that's one of the motivations for developer gold plating is, oh, I've got this new toy. I want to try it. I want to learn how to use it, and I want to get
Yep.
paid to learn how to use it.
That's definitely one motivation. Another one example would be, again, just being burned in the past. So I have a story I do in this talk about working on one application where the users wanted to customize the email notifications that were coming out of the system so often that it became like a major uh, source of items on our backlog. It's just like go into the back end and update the text in this email all the time.
Hmm.
And so the very next system that same team built that system with WYSIWYG. What you see is what you get editor for email templates that the system would send. And of course, ironically, that system never needed to change the email templates. So it was just we were burned on this in the past, so we're gonna never make that mistake again. We're always gonna build this feature if it's needed or not.
No, what's the solution then?
Yeah, I mean, so the solution in this one is fairly simple. I think it's just stop doing that. Follow an actual agile process, put things through review of the whole team, let the business users decide what the features need to be. Only really add stuff like that that's purely architectural, like if how you choose to organize your application, whether you're doing layers or vertical slice architecture. The users aren't going to care about that. But
Right.
when it starts to get into features, and it's features that nobody asked for, like
Hmm.
boom, you're gold plating.
Yeah, maybe I think an agile methodology would help in this case because, especially with frequent code reviews,
Yeah,
because then when that starts to creep into that scope starts to creep into your application, people know about it. Someone else has
that's
eyes
right.
on it. It's not
That's right.
just David over in the corner building his cool tools. Now,
That's
now
right.
Jay takes a look and says, "Why are you doing that, David?
That's right.
Knock it off."
Yep, code reviews is a good solution to a lot of these problems. Reviewing pull requests, having senior people review junior people's stuff, but also having a CI/CD environment where as the team is building stuff, the business users can actually interact with the application as it's being built.
Hmm.
Is also a valuable way to do that. So that's something we do at Trailhead with our customers. Is at a minimum once a week we're meeting with all the stakeholders to say, here's how things are going. But at any point between those weekly meetings, they can go into the integration environment and see the application as it's, basically been built up to the minute.
Interesting. All right, let's talk about another problem.
Okay. So another really popular one these days is what I call lasagna architecture. This is basically like layers for layers sake.
Mhm.
Like lasagna.
I
Uh,
love lasagna.
lasagna is great. Um, I think us developers must be hungry sometimes when we're writing because we talk about spaghetti code and lasagna architecture. But sometimes just layers for layers' sake, or layers because you've always seen it done that way. creates a lot of extra complexity. I think we all start out these layered applications thinking like this is nice and clean and it makes perfect sense. This layer is in charge of, let's say, persisting data to the database, and this layer is in charge of business logic, and this layer is in charge of presentation. Those types of things seem really clear and like,
Mhm.
okay, I know exactly where to put things. And it does usually start out that way. But then the most common task that we're asked to do as developers is changing some existing feature.
Okay.
And it's actually really hard to change an existing feature when it's across multiple layers
Now you
where
have
you
to
have to go in.
touch seven
Yeah,
different layers in this seven layer
that's right.
burrito.
That's exactly right. And so I've seen applications where seven would be great because they have 15 layers, and you start to think like, what are these things even doing? I think some of these objects are spun up just to spin up another object,
Right.
and they don't do anything else. So layers for their own sake can be problematic, and there is a direct solution for this one, and that's an architecture called vertical slice architecture, which basically says put the things that change together. So all of the code for a particular feature and basically all the different layers that you would normally think of would all go into one spot.
Yeah, I actually had Jimmy Bogart on this show about a year ago
Hmm.
talking about his tool for doing vertical slice architecture.
Mm-hmm.
And now I've forgotten the name of the tool. Are you using any tools for that?
I'm guessing maybe mediator.
Mediator. Thank you so much.
Yeah.
Sorry, Jimmy.
You do too many episodes, you can't remember it all. Yeah, there's mediator is a library that's very helpful for that. There's other ones out there as well that do the same type of thing, but yeah, it's basically a great way to sort of separate those chunks of code from each other so that they don't explicitly rely on each other. You could almost think of it as like a way of doing dependency injection for your layers or something.
Okay. This is good stuff. Keep going.
Okay. Uh, well, another common one that I see very often is what I call the like rolling your own
Mhm.
solution. So a team will maybe have had a bad experience or been unable to customize some third party thing like a logging framework or a security framework, identity and access management. They couldn't quite get it to like do exactly what they wanted, and maybe that was lack of understanding of it, or maybe it was lack of customization in the particular tool that they picked. But for whatever reason, they were like, okay, this logging framework isn't going to work for us, and so maybe all logging frameworks won't work for us. So let's make our own logging framework. The downside, obviously, here is that if you use one of the popular logging frameworks from GitHub, from the community, you're going to be using something that literally hundreds of thousands, if not millions, of people are testing every day.
Right.
And you're going to have really, really good test coverage. It's going to be, in a lot of cases, it's going to be done by a lot of real experts in this area. And when you go and try and roll your own solution for it, usually you fall down somewhere. And sometimes it's fun. Like I see a lot of people doing um, microservices architecture and coming up with their own queuing system, message queuing system for those different applications to communicate with each other. Because it's kind of a fun problem to solve, I think, if you have a computer science degree in your head. But
I don't.
obviously, but obviously, things are more complicated than they seem usually, and so things
Yes.
like retries, guaranteed delivery, stuff like that is not as easy as it seems like on the surface.
Right.
And the chances that you are going to solve something as well as like a whole community of experts already did is obviously pretty low. Then you get problems like you hire somebody new and they know all of the logging frameworks that are popular, but they don't know your special in-house one because you
Now you have to
developed it
teach
in-house.
them.
And how would they know? Yeah. So sometimes I see that where people roll their own solution. Um, the solution to that is to just basically understand some good solid rules for how to pick a third party library, to spend extra time learning about those libraries, make sure you really understand how they can be configured. Maybe the thing you want to do that you're trying to get these to do is ill advised, right? And
Hmm.
that's why they don't do them. So spending a little extra time on it, and not trying to just because it's a cross-cutting concern, trying to rush through it, isn't a good idea. So that's kind of a solution there.
Yeah, even if you're able to do everything perfectly and create something just as good as all of the commercial and open source tools, the amount of time spent in building a custom tool is exponentially larger. It's orders of magnitude larger than picking one off the shelf.
Yep.
And this might be, I don't know if this is in your talk, but related to that is this idea that customizing, taking a tool and then over customizing it. I used to, again, I'll go back to my consulting days. We would work with tools like SAP, for example,
Mm-hmm.
and it has a lot of customization, and customers always wanted to just customize the heck out of it
Yeah.
because they felt like their business was special. Yeah, this is generic. It's built for, I don't know, department stores, but we're a special department store. Our rules are so different. We've got to hire consultants and bring them in and
Yeah.
do all this customization. And I don't know if that's always a good idea. It adds a lot of complexity.
Yeah, that's a complicated topic there. Obviously, I own a custom software consulting company, and so custom is something that we like, and we
Sure.
see
I
the
mean,
value
there
in.
there there is there's a short term benefit for the consultants to do
Yeah,
that,
sure.
but if
Yeah,
you're there for years and there could be a long term cost even to the
yeah.
consultant after a while.
When clients occasionally come to us and say things like, "We want you to build a custom logistics or warehouse management package for us," or something like that, we'll be like, that problem
Those
is
exist.
they exist for sure, but those problems are pretty well solved. There's dozens of options out there if you have certain requirements that you think might not be common. Um, but then there's on the flip side of that, there's things that truly make businesses unique, and that's
Right.
the thing where we think custom software is really valuable. If you have a differentiator between you and your competitors, and by using some off the shelf ERP to run your business, you would have to change your processes and lose that custom special
Right.
thing, then we say, yeah, it makes sense to build custom software around that. And that could be anything from like a really, really great, think of Apple, right? Like their differentiator in a lot of cases is just a really, really great experience. And that might be your differentiator in your business. Like we built this thing on an ERP and it's kind of a clunky UI, but it
Right.
works fine. But we don't want our customers using a clunky UI because our differentiator is a really, really great experience for our customers. So then maybe custom makes sense.
Yeah, I think just being deliberate about how you make that decision, whether you're going to use
Yeah.
something off the shelf versus building yourself, figure out what are the benefits and the costs of doing that is
Yes.
um, is probably the differentiator. Because I think you made a good point that sometimes there is a good reason to roll your own,
Mm-hmm. Yep.
but sometimes it's not. And sometimes changing your process is okay. It doesn't. You're not going to lose anything just by changing your process. It'll be a lot cheaper and
Yeah.
almost no downside.
Right. There's a lot of overlap here between rolling your own and gold plating, right? Like
Right.
you could secretly, as a development team, decide to do some big cross-cutting concern and do it yourself without ever communicating that, and that's also gold plating.
Mhm.
But it's also rolling your own. So that's a good example of how these things can kind of overlap a little bit with each other.
All right. We still have time left. I know you have like 10 or 12 of these, but let's get through as many as we can. Some of the problems.
Sure. I'll mention one others, and then we can talk a little more about solutions too.
Okay.
But another very popular one is what I call shiny object syndrome. So this is I went to a conference, I heard about microservices, I understand it 1 hour's worth of hearing about it, and I just now want to do microservices on every project, whether it needs it or not. And I don't maybe totally understand the trade offs, right? Because everything in engineering is a trade off.
Yes.
So what am I giving up to take on microservices? And if I don't know that answer, really all I'm doing is chasing a new shiny object. It's the hot newness that I saw at a conference or on a YouTube video or something like that.
Yeah, really similar to gold plating, except you're not talking about features. You're talking about the technologies and the architecture.
Yeah, and it might not even be a secret, right? Like the whole team might be like, "Yeah, let's do microservices." And if nobody's taken the time to say why microservices and what are we giving up by doing microservices, and one of the answers to that might be, what we're giving up is simplicity, or immediate consistency is another thing that you give up in microservices architecture. And if somebody doesn't know that, then the whole team, including maybe the business users, could be gung ho about, yeah, let's do this new architecture. Um, whoever, Uber is using it or Google is using it or something like that. So it must be great. And it must be the right solution for our problems too, even though we only have 100 users on the
Yeah,
system.
our problems are not the same problems that Uber has.
Right.
Yeah, that's a great point. I think Joel Spolsky used to have a podcast, and he referred to something like this as management by airplane magazines, where the CIO would be, or the CEO would be on an airplane reading the magazine, and he'd read an article about microservices,
Yeah.
and it would be so inspiring that he would land and tell the whole team,
We're doing microservices.
"We're
all
doing
the
this
time now.
thing."
Yeah. Yep. Yeah, that's a great example of shiny object syndrome that just happens to come from an executive instead of a developer.
Right.
Yep.
All right. Let's talk about solutions. These are solutions that cut across all these problems.
Yep. So probably the most important one is using good agile methodology. So if you're doing anything where you're not including everyone in decisions, there's a chance of things like, gold plating, or rolling your own where it's not necessary. If you're doing anything that's too big or too siloed, then you're not going to have people looking over each other's shoulder and giving good feedback about, hey, do we need to do it that way? So that's the first place I would start, is making sure that you have a good agile process. And you can tell you have a good agile process, I think, when everybody has a chance to be at the table at the beginning and end of a sprint, or whatever you want to call it, and that you're taking very small bites. So you're not launching to production, once a year, once a quarter. You're doing it once a month, once every 2 weeks, maybe more often. That's how you can kind of tell you're doing good agile.
Fast feedback. That's the key to agile.
Exactly. Yep. Yep. And that's why everyone involved has to be at the table, and why it has to cycle quickly. Yep. Another one is, there's just a couple of funny acronym rules that people talk about in our industry. The KISS rule, keep it simple. Software developer, I like to say, is what the second S stands for. And then the other one is YAGNI. You ain't gonna need it, is that one. Those are both things to, I think, always kind of just have in the back of your mind as a software engineer. Is this really necessary? Like, is this email template editing functionality that we're putting in here something that actually is going to get used? Or are we solving a problem that hasn't happened yet because, we've got trauma from a previous project or something? And then keep it simple is going to fight things like lasagna architecture, where you're like, okay, we could have 8 layers in this application. And it might feel really cool when we start out to know, like, okay, if it's business logic or if it's validation, it goes here, but if it's business logic, it goes there. But is that really what you want when you come back and edit things? Or you're going to want to open 8 or 10 files to, make one field a different name on one object or something like that. So that's not a good, not a good keeping it simple. Another one is adopting proven solutions. So a lot of teams will go to a conference or read a blog about some new thing, and they'll say, this is the thing that we want. This is the architecture or the tool or the language that we want to use for everything now. And the problem, of course, being that when it's new, not even maybe anyone in the industry knows what the trade-offs are yet, if it's really bleeding edge. Also, obviously, community support, documentation, these things usually lag, right? And hiring people that know something that's cutting edge is tough. So if you're trying to do something that you want to last, to span the years, then using proven solutions the team is familiar with, that have support, have documentation, have a community, have the ability to hire people that already know it, can be really valuable. And then I always tell our clients to use those cutting edge things to do proofs of concept. So we think this is something we want to try. We're going to build a quick application to just try it out and see like what issues we run into. That's a perfect place to adopt new things.
Awesome.
Uh,
Any other things we can
yeah.
do to address this?
Yes. Another one that I think is really valuable is the idea of dry from solid architecture, but then also
Dry is don't repeat yourself.
that's right. Yep.
Dry
Don't
is
repeat.
don't repeat yourself.
That's right. And then I always say dry, but in a wet way. So wet, WET, stands
Okay.
for write everything twice.
I didn't know
And
this.
yeah, so wet basically says if you repeat something, it's okay to repeat it twice because if you've been a software developer for very long, you've seen the pattern where when you try to make something abstracted away, as soon as you say, I'm copy and pasting code, I'm going to write some library that both those places can call. Usually, what ends up happening, often what ends up happening, is that those two places that are calling it start to diverge what they need.
Mm.
And it just seemed very similar, or similar enough that it felt like you should abstract that logic away. And what ends up happening is you have all these if statements in that
Mm.
abstracted logic that says if it's calling from this place, do it this way. And pretty soon you're like, okay, I've got two different solutions that are like zippered together here,
Right.
and I should have waited a little bit. So wet basically says write everything twice in separate places. It's okay to copy and paste it initially. When you do a third time, that's
That's when
when
you
you
start
say,
thinking about
okay, this
abstracting it
might
out to
actually,
a
yeah,
common library.
exactly.
Um, okay. Yeah. I actually had a manager once who scolded me, said it was a major architectural flaw that I copied something twice. And I
Uh-huh.
tried to explain exactly what you said. The
Yeah.
rule I've always had is if you have to do it once, copy and paste is fine. The third time, then you start to abstract away to a common library.
Yep.
I lost that argument.
Makes sense.
Thank you for that.
Yeah, I got you backed up here years later.
3 years later, yeah. Uh, anything else that we can do to address these concerns?
Yeah, there's lots of other ones. I could give you another example. Yeah, another good example is thinking about the principle of least astonishment. This is something that normally applies more to UIs or to like ergonomics and things like
Mhm.
that. But I think it applies equally as well to development. So this is basically a rule that says that a component or system should behave in a way that most users expect it to behave and not astonish or surprise them.
Mm.
Right. So the principle of least astonishment means you should never really surprise your users. So instead of a checkbox, using some sort of a weird interface that you feel like is a cool new invention for a checkbox is going to astonish them because they'll never have
Right,
seen your
right.
custom thing before. I like to apply the same thing to engineering. You just mentioned a little bit ago about inheriting some software from another engineer that made a decision that you were saddled with. Uh, if you think about the principle of least astonishment, when this code belongs to someone else besides you, are they going to look at it and be like, why is everything in a different place? So I'll use an example. Uh, I'm a .NET developer. I know you are too, David. MVC, when that was first invented, uh, for ASP.NET, it is basically by convention, right? So your controller classes have to end with the word controller, and they have to be in a controllers folder or subfolder. And I encountered some software where somebody had basically gone in at a low level and kind of changed all of that configuration, that convention configuration,
Mm.
and they had their stuff all over the place in different places. Now, when a new team comes in and inherits that, they're not going to understand where anything is because they've seen maybe hundreds of MVC applications before where the controllers are in a controller folder. They'll never have seen one where the controllers are, spread all over the application. And so there's going to be a lot of astonishment there, and it's going to create a lot more chance of bugs, a lot more difficulty to maintain, just because of that like uniqueness to it.
I totally get that. There may be a reason why the developer decided to configure it that way, but it's and the developers coming in, they can learn that, but it's a mental speed bump. It's one more task they have to overcome
Yep.
before they can actually start being productive. And
Yep.
making it more intuitive is a good solution. Okay,
Yep.
we're just about out of time here. Where can people go to learn more on this topic?
That's a great question. Well, I haven't blogged about this yet, but I probably will soon. So they could go to trailheadtechnology.com/blog if they want to follow that. And then obviously attending conferences where I'm doing this talk and reaching out to me at jtower@trailheadtechnology.com and we can talk about that.
Jay, as always, it's great to talk to you. Thank you so much for sharing your knowledge.
Yeah. Thanks for having me, David. All right. Keep solving problems with the best tools that you have available to you, your technology, and your friends.